I'd like to welcome everybody to the session this morning. My name is Brad Brown. I am an instructor and consultant with WebAge Solutions. And just a little bit of background about WebAge. WebAge provides corporate training and consulting services around a broad range of IT topics. Um, More than I can mention, my specialties revolve around architecture, software development methods and practices, data, and big data. But our courses include all aspects of infrastructure, development, programming, so a broad range of solutions to meet any corporate needs, and all can be customized as needed as well. Now, I'm not on the sales side, so I'm not going to try and talk about that, but get in touch with your rep should you have any needs. And of course, our website is webagesolutions.com. I'd like to welcome everybody to the session this morning. We're going to be talking about a selection of topics that are important for DevOps. And this material is drawn from a number of different courses that WebAge puts together. So we've assembled some of the most popular and meaty sections of those courses into this session today. And the things that we're going to talk about are DevOps core concepts, how we can start DevOps practices inside your organization. And then we'll talk about two slightly more technical aspects of DevOps: continuous integration, continuous deployment, delivery, and what those processes are and how they're leveraged to gain business benefit, and Docker as a specific technology, the containerization technology. A few logistical notes before we move forward. We are scheduled to end at 1:30 Eastern time today. We will not go past 1:30. I try to be pretty close to that. There is going to be time for Q&A at the end. I'll talk a little bit more about Q&A in a minute. And because this is a fairly long session, I am going to insert a break of about 10 or 15 minutes at an appropriate time, roughly in the middle, because this is a long time to go without additional coffee. You'll see, coffee is kind of a big deal for me. Now, we do have a very large group. So all attendees are going to be muted. Normally we don't do that in virtual sessions, but this is such a large group, it will be necessary. So everybody's going to be muted, but that doesn't mean that you can't participate. I'm going to encourage people to ask questions using the chat feature of GoToWebinar. And I will address questions at kind of appropriate times in the talk. I'm not going to interrupt a slide for a question, but as we get to transitions between topics, I will come back and answer questions, and I'm very pleased to address anything that I can, any questions that you can submit. I do want to point out you have the material. It should have been distributed to you already. I have lightly edited that material for time. I've just deleted a few slides here and there just to be able to streamline the content a little bit. So if you're following along on your own copy of the material, and it looks like I've skipped over a slide, I've skipped over a slide. I believe, as far as I know, there will be a recording of this presentation made available to all attendees later, and you will, I believe, be receiving a link to it, or it'll be posted to the WebAge Solutions website. But the recording should be available later. And good, thank you. Okay, just had a chat question there. So without further ado, let's move into some of the material. And we're going to start with DevOps. And why are organizations interested in this thing called DevOps? Well, actually, let me back up just very slightly and say, what is this DevOps thing that we're talking about? Well, there are a lot of different valid definitions of DevOps, and we're going to talk about it in a little bit more detail and kind of develop a functional definition of DevOps as we go through this material. But for our purposes, I'm going to say that DevOps is the use of a unified, continuous, relatively low friction process that allows change to flow smoothly from coding through to production. Now, there are a lot of definitions of DevOps, and you may have heard things that don't sound quite like that, but you know that definition I think is pretty broad, and it certainly works for me, and it's consistent with all the material. So again, what DevOps is a unified, continuous, low-friction process that flows change from code into production. Why are companies so interested in DevOps in the last few years? Well, corporate environments, the business environment that we're in has changed dramatically. We face many new challenges in terms of the time that we need to be able to respond to change, which is becoming less all the time. Competitive challenges, which are becoming greater all the time. And environmental challenges, the things that are going on in the business world, make it increasingly challenging for organizations to just kind of plod along, if you will. So many organizations wish to employ DevOps practices to rapidly develop reliable and scalable services that are critical to their business and do that while respecting their needs for time to market and delivering business value. We have both business and technical benefits out of DevOps. Now, the technical benefits are around things like continuous delivery, the ability to deliver software relatively continuously rather than in big, giant, scary chunks. Reduction in the complexity of the things that we're dealing with. We tend to deal with things in smaller chunks that are simpler and therefore easier to manage. Greater agility in problem resolution. And their benefits, technical benefits, go on and on. All of these technical benefits, though, are really in the service of what we want to achieve as a business. And the primary things that we're interested in a business is usually around agility in the delivery of business benefit. In other words, how can I, as an organization, be more flexible in delivering business benefits to my customers, my consumers, to be able to realize the value from those changes that I'm implementing? I may also be interested in increased stability. Some organizations are driven by a need for increased stability simply because they have an environment that isn't particularly reliable. They really need to do something about that. Well, DevOps can help there as well. And the last one on this slide, again, they go on, but the last one on this slide is being able to focus on competitive advantage rather than keeping the lights on. In other words, the ability to invest more of our IT spend on business value and deriving new business value rather than simply maintaining IT capabilities. Now, what is this DevOps? Well, I've given a bit of a functional definition, but let's be a little bit more precise. First of all, it's important to realize that DevOps is not a specific methodology. It's not like Scrum or XP or these software development methodologies where you can buy the book or take the course or whatever and say, I'm following these things, and if I do A, B, and C, I'm following the Scrum methodology. DevOps isn't like that. It's not a specific thing. It's a collection of practices and culture and tools, the way that people work and attitude toward things. It's also not a detailed framework like ITIL, the Information Technology Infrastructure Library, or COBIT, Control Objectives for Information Technology. It's not one of these very well-defined frameworks that you could simply say, here are the pieces of the framework I'm going to make use of, and I'll just select these and start running them. Again, it's a lot more squishy than that. It's about people, process, tools, partners, attitudes, culture. It encompasses a lot of those things that we think of as non-functional things, agility and reliability and scalability. And it depends on having a focus on some things that are really kind of cultural, about how we share knowledge and how we collaborate, what we automate, and our focus on automation rather than doing tasks, and a focus on delivering value and that rapid delivery of value rather than simply delivering kind of big system at some arbitrary time. So if we can continue this somewhat hand-wavy description of what DevOps is, well, it's an organizational culture. It's an organizational culture that encompasses both technology and process. It's a set of practices that encourage transparency and candid communication between stakeholders. And those stakeholders are across a lot of areas that are traditionally silos. They're within IT, different areas within IT, including obviously dev and operations, but also other areas, QA, test, user experience, security. There are also stakeholders that are external to IT, business, governance, controls. By using these practices, by using automation, measurement, we can track the flow that code goes through as we go through develop, release, test, maintenance. And our intent is to make that process more reliable, more scalable, more sustainable, more repeatable. And importantly, being able to operate in much smaller chunks. And this will be a theme that I'll pick up on throughout this material. By having well-defined processes and automating those processes to the extent that is reasonable, and reducing the manual tasks, the manual touch points that are required, it enables us to have change which is in smaller amounts. So, other aspects of DevOps include the creation of common goals for development and operations, and indeed all other stakeholders, for getting applications built and deployed as quickly, safely, and efficiently as possible. And the key piece in that bullet is common goals. It's bringing together the common goals between different parts of the organization. It's having different stakeholder teams like operations working closely with teams who are traditionally at somewhat more arm's length, developers, to facilitate agile and ongoing deployments and avoid over-the-fence handoffs, to be able to allow more frequent, smaller changes instead of infrequent, very large and frankly, scary changes. It's about building reliable and repeatable processes that we can not only use to support the business, but be able to leverage to be able to be more effective in our use of our people and our technology. Now, there's a lot of tall orders in here. DevOps depends on, first and foremost, being able to have collaborative cross-functional teams. And part of this slide is about how you tell whether you're really there. Do you have issues? I mean, think about your organization. In your organization, do you have builds, artifacts that are figuratively tossed over the wall from one group to another? Do your different parts of the organization have a high degree of visibility across different parts of the teams and different silos? Is a team's responsibility one that ends when they finish their artifact, when they produce their work product, and they just wash their hands, or do they stay involved in it afterwards? And do you have effective communications around the processes that are used to actually get software into production, releasing, builds, defect management? So ask yourself about the behaviors that you see in your organization, because a lot of those things, if it that feels like what your organization is like, there's a tremendous opportunity in DevOps to be able to change the impact of some of that. And a lot of that depends on the culture and the way that people actually really work. So there are a number of models for how we think about culture and cultural aspects. And cultural aspects is probably the hardest part of DevOps. Some of the cultural aspects of your cross-functional teams, those aspects that your cross-functional teams will need, are captured by this acronym A cubed and C, which really just stands for 4 key cultural aspects that will be important. 3 of them that start with an A and 1 that starts with a C. Shared accountability, automation, analytics, and a culture of communication. And just briefly, shared accountability is that culture that everybody who is a stakeholder of a process getting a piece of functionality into production. And all those stakeholders are development, operations, security, all of those people, all of those individuals believe that they have a shared accountability for the end product, for getting that piece of functionality actually running stably, is that even a word, in a stable environment in production. And that shared accountability isn't, if I'm a developer, I'm going to write my code and make my units test passed. No, it's actually that thing is running in production. If I'm in operations, it's not. I'm going to put it in a production environment and monitor it. It's that end product. That shared accountability is probably more than anything the biggest cultural impact that can happen when you effectively implement DevOps, because it brings people towards a common goal. In support of that common goal, the second of these characteristics is automation of almost anything. Now, I'm not sure I'd literally go to almost anything, but we have a strong focus on automation. And we have a strong focus on automation because when we automate something, when we invest the time in creating an automation, as opposed to simply performing the task manually every time it needs to be performed, a few wonderful things happen. One wonderful thing is the incremental cost of performing that action again is effectively zero. We just run the automation again. And that means we can afford to do that thing over and over again frequently, because machine time doesn't really matter much, but people time is really important. So automation is an enabler of being able to do something over and over again without overwhelming cost. But it doesn't end there. To be able to automate something, we have to understand it and we have to document it. The automation becomes documentation. So we tend to have a strong focus on processes and what is actually being done, rather than somebody sitting down and using their knowledge to do something that, Alice may do it one way and Bob does it slightly differently and Kathy does it slightly differently, just because they have slightly different backgrounds. And one day, Alice may do something and make a mistake and doesn't realize it. And so automation reduces variation. It reduces mistakes. It increases the quality of the things that come out of the automation process, which makes life much easier for people who are downstream. And that capture of the process inside automation means we can repeat it at multiple points throughout a larger value stream. So the way that I deploy into a test environment, say, could be exactly the same as the way that I deploy into a production environment. And I can reuse that. And it's not just a matter of reuse. Now when I go to deploy into production, I've done it 57 times before because it's fully automated. I can have confidence in it. All the confidence and repeatability in the world, they're good things, but when we add analytics, or metrics, if you will, analytics just starts with an A, then we have the ability to actually measure what's happening in our processes. We can use these measurements to discover places where we need to improve, or discover what's causing us to take longer, or what's causing introduction of defects, say. And this culture of analytics, this culture of measurement, should be pervasive in a mature DevOps organization who essentially wants to be able to make fact-based decisions about the things that they're doing. And then all of this is supported by the last item, the culture of collaboration. A culture that, regardless of where I am in the value stream, regardless of what organizational unit I'm in, my purpose is to collaborate with the other people on the extended team. My purpose is to be able to collaborate with people to get an end product done, to be able to share what I know and learn from what other people know, so that I can tell people downstream what my needs are, and people downstream from me can tell me what would make their life easier. And that collaboration ends up supporting a significant improvement in overall process efficiency. So these are a few of the key cultural, kind of squishy, important things. How do we actually move forward? Well, as we're thinking about moving forward and implementing DevOps early on in an organization, there are a few kind of useful questions to ask. First, what do we actually want to get out of this exercise from a business point of view? What's the optimal or required business outcome? And this is an important thing, because we often start thinking about DevOps as applying a bunch of cool technology, or wouldn't it be fun to be able to do this? It's easy to forget that the reason that we do this is in support of some business need. And depending on what those business needs are, we may have some very different ideas about what we want to do. If our business need is around stability because our systems don't appear stable enough in the eyes of our customer, that's a very different set of requirements than a business need that says we're just too slow to get functional changes out to our customer base. We need to be able to get changes out faster. That's a kind of different desired business outcome. So the first question to ask in starting a deliberate DevOps exercise is always, why would we want to do this from a business point of view? Now, the second good question is, how are current processes meeting the requirements? Most organizations have a lot of processes that actually work quite well, or might need a little bit of tweaking, but maybe they just need to be wired together in a different way. There's a lot we can gather and learn from existing processes that we should be trying to leverage. So think about how current processes are meeting requirements. And then think of a project. Where are you actually applying DevOps for the first time? And why is this project or this kind of process you're trying to optimize a priority for change? In other words, why do this rather than something else? And in thinking of that, who benefits from that change in their daily work? Where does the actual benefit come from? Now, there are a few kind of vocabulary terms that you hear frequently, and I'm not going to cover all of these just in the interest of time. But some of the jargon terms that are kind of useful to know are around silo. Silo is a great term. The term silo refers to a part of the organization or department or group who acts essentially in a silo, in isolation. And this is the opposite of the behavior that we want to see in DevOps. Silos are, the slide says, the antithesis of DevOps. Because remember that continuous flow process, removing friction, collaboration, shared accountability. Silos work against all of those things. Silos tend to fall apart when we have an environment that has a high level of transparency. Transparency is really the openness to other groups, other stakeholders, sharing what we know, sharing what's going on inside our areas. And this is both requires and encourages cross-team communication. And as part of that, another piece that's important in DevOps, and another important vocabulary piece, is notification, which is simply the communication when events happen, both when they go well and things that go wrong. Telling people frequently when things go right or when things go wrong is important to people being able to have a stake in that overall shared process. And the last one I'm going to cover here is measurement, because anything there's a saying, you can't improve what you can't measure. So being able to measure things, including some of those squishy things like cultural aspects, is important for being able to guide the evolution of DevOps, because it really is much more of a journey. It's a journey that has a number of goals. Now, again, I'm not going to talk about all these goals. I want to talk about just some of these goals. One of these goals is ultimately agility. Now, we talked about business agility as a business benefit earlier, but as a goal, this more general notion of agility is something that's important in the DevOps environment. And when I speak of agility here, the slide talks about a specific example. Server environment should be able to reload it in a short amount of time. Yeah, very specific. I want to be more general about this. As a goal, agility is the ability to be able to do something on relatively short notice without a lot of dependencies and be able to kind of deliver something relatively small relatively quickly. And this notion of agility is what enables us to be flexible in our processes, and it's what enables us to be able to develop and change those things as we go. One of the ways that we do that is by shifting left. Okay, now shift left is one of those jargon terms in DevOps, but what it means is taking decisions, sometimes responsibility, that happens downstream in a process and moving it earlier on. A very simple example of this is the more automated testing we can do, that we can take out of a test process that would have happened later and actually bring that into the build process so it's repeated every time we change code. That shifts the testing left in the overall process and identifies defects faster. And as a general rule, the more we can shift left, the more responsive we'll be able to be, and the more issues we discover and deal with afterwards. And the last one on this slide, I see the chat message, I'm going to address it in just a moment, is happy people. That seems kind of like an odd thing to say. How is happy people a goal? Isn't that a little bit too squishy and hand-wavy? Well, turns out that the satisfaction level of people in their jobs is actually a really good indicator of how effective you're being at developing processes that work, keeping people focused on things that are important, avoiding the grunt work that nobody really wants to do. You know, the more we shift from keeping the lights on to developing new things, the happier people are. And in fact, a key metric of DevOps implementations is staff satisfaction. So having happy people as a goal and actually measuring their happiness, their satisfaction, is actually an important thing to the company as a whole. Now, check this message here. Oh, thank you. Yeah, someone pointed out a typo. Thanks very much. So what happens? What happens to business when we implement these things? Well, we change the way that business works. So now, in a mature DevOps environment, business teams themselves, on the business side, not in IT, but in business, they're very highly motivated by time to market. They're very highly motivated by their ability to get some change out into the market. And their behavior starts to change. They're going to start to see that they can get smaller changes more frequently. And they'll be able to see components, things that you're working on, earlier on in the development process, which will dramatically reduce the amount of rework that happens later. They're going to see less churn in requirements because the likelihood that they're going to have something that meets their business need is actually much higher because things happen more frequently in smaller amounts and they get to see parts of them earlier on in the development process. And all of this drives business agility. Frequent small changes help business to adapt to what they learn and to competitive activities. So think about the difference on the big picture. In a classic enterprise environment, we build these enterprise applications, and typically it takes anywhere from, say, 6 to 18 months between when we gather requirements and when we actually ship something into production, where customers actually see it. And it's usually kind of on the higher end of that. And so what that means is business is motivated to request everything they can possibly think of, throw it all into the requirements bucket, including a lot of things that they don't necessarily know or understand what they need or what the result of having those features in, but they've got to get them in because it's their only chance. And they end up getting a product that has a ton of stuff that was relevant 12 months ago, somewhat less so now. And some of that functionality is not necessarily things that they really expected because they didn't get a chance to have input during the process. In a mature DevOps environment, the picture changes very significantly for business. From a business point of view, they can make requests into IT, and those requests can be satisfied with business involvement to determine prioritization. And a typical request might go in and come out in production maybe a few weeks, maybe a couple months later. It depends on the organization. But there's a steady stream of them, and they're relatively small. So now when business sees competitors doing something, they don't kind of throw a bunch of things into a request bucket and kind of wait a year or so. They throw a bunch of things into a product backlog, and those things get prioritized, and some of those things start coming out pretty early, and they can actually start to respond to competitive actions. They can also see what works and what doesn't. Say, oh, this idea we had, it sounded really good, but actually we need to do this slightly other thing to really make it a great idea. And you actually have the scope and ability to be able to be that agile and deliver that. So in driving these business outcomes, we can have a significant positive effect, not just on how IT works and on the satisfaction of people in IT, but also on the business of the organization as a whole. And ultimately, we want to be able to make sure that the way that we're doing that, the way that our extended team is carrying out these activities, aligns to the core values and missions of the organization. And that introduces another model. And this model is CAMS. And these are 4 aspects that are important to how the teams work: culture, automation, measurement, and sharing. We can think of these as kind of the core values of DevOps. Starting with culture. And culture is kind of it's that intangible thing that's absolutely essential for DevOps success. Culture is the way of life in the organization. It's that pervasive and enduring property that the organization has that's embodied in how people think and act. It's expressed by a whole bunch of important things, not just the ones on the slide, but the ones on the slide are those things that are critical to DevOps. Understanding the motivation of other groups is part of that shared accountability and culture of collaboration. An important part of culture is being able to understand what other areas need, not just your area. An important part of culture is the ability to trust the people on the extended team and to eliminate blame. Now, let me pause for a minute and talk about elimination of blame for a moment, because this is kind of an important concept. Things go wrong. Things happen. We try experiments and they don't go right. We do things with the best of intention and something blows up. A blame culture is one where we would say, look at Bob. Bob pressed the wrong button and it blew up production. Bad, bad Bob. And a couple things happen. Now Bob and everybody who knows Bob now they're afraid to push the button. They're afraid to take action because they know retribution will happen. And the other thing that tends to happen is we tend to put in all these processes to make sure you don't press the button the wrong way. Maybe we cover the button with a bunch of stickers or cover it up with some protective cover. And now you need to go to somebody to get sign off before you lift the cover and press the button. And a culture of blame is one that effectively, it doesn't intend to, but what it effectively does is stifles action. If we eliminate blame and Bob presses the button and production blows up, then our question is not how bad is Bob and what can we do to prevent that from happening again. It's what led to that? What vulnerability is it in our systems, in our processes, that would mean that pressing that button actually had that drastic negative effect? And so is there something that we can learn from this so that you can press the button because you need to, and it doesn't have this significant risk around it? This trust and elimination of blame opens the doors to being able to unlock people's creativity and unlock their experimentation. And we do this partly by building in processes that are somewhat more mistake-proof. Part of this is being able to embrace failure as necessary for improvement. If we're not failing, we're not trying. We're not experimenting enough. We're not pushing the boundary enough. Now, I don't want to embrace failure to the point where I'm deliberately causing problems that are going to be exposed to, say, production, to customers. But I do want to allow failure to happen, hopefully in a controlled environment, so that I can figure out what those boundaries are and improve them, deal with them, manage them. Because if I'm afraid to fail, I'm afraid to try and learn. An important part of culture is a focus on process and bottlenecks to those processes. So rather than simply accumulating a big pile of knowledge or just doing things because, hey, I know how to do this, we focus on the processes because the processes are things we can modify, we can measure, we can automate. We focus on what the bottlenecks are, what's holding us back from doing something better. This focusing on process rather than task unlocks our ability to improve our future. It's culturally often very hard for organizations. Because if you have an organization whose culture is all about deliver now, what their implicit message is deliver now, don't invest in the future. And having a focus on process and bottlenecks allows us to be able to think about the future. This focus and activities like automation drive towards a culture where we're trying to eliminate unplanned work. Unplanned work are those things that we didn't anticipate. It's those things that, oh, I'm building this server and oh, I ran into this thing, I got to take care of it. By focus on process and repeatability and reliability of processes, we can try and eliminate, we'll never completely eliminate it, but minimize unplanned work. A key cultural value is candor and transparency, honesty and transparency, which is kind of the flip side of understanding motivations of other groups. It's about being able to be open and transparent and honest about what you're doing, what you see in others, what you see in the process. And then lastly, this is more kind of organizational effect. We see the emergence of dedicated cross-functional teams, by which I mean we see the emergence of teams who include stakeholders from a number of different areas. They're cross-functional in the sense that the team is composed of people from different organizational units. We don't necessarily go and reorganize the whole organization. We don't have to flip the org chart on its head. But we see people working together effectively in cross-functional teams. So a question here. Okay, I need to have a quick process check here. So I have I have a chat message from one person who lost audio. I just want to check if audio is okay. Can people hear me okay? Just send a quick chat message if you can hear me okay. Yep, looks good. Okay, thank you. Thanks. Okay, being overwhelmed by messages saying it's okay. Okay, thanks. It seems to be just one attendee with the problem. And just again, slides and audio. This presentation will be made available afterwards. Not instantly, but they will be available afterwards. Okay, good. Oh, good. Gary, thanks. Excellent. Good to know. Thank you. Okay, so everybody's got audio back. So that was set of core values around culture. What about automation? Well, automation is the activity of taking some activity that a person needs to intervene on, to maybe type on a keyboard or whatever it happens to be, and make a machine be able to do that. And automation gives us a bunch of valuable things. One thing is it allows us to focus on value-added activities. Essentially what it does is it makes the marginal cost, the cost of doing one more repetition of something, of an activity, effectively zero, because the machine's taking care of it, we're not. And that opens up tremendous possibilities. It means that some process that adds some value, instead of being kind of this very rare thing because it takes an investment in people's time, I can repeat it over and over again. And that's tremendously valuable. You'll see that when I talk about continuous integration. Automation reduces the variation in the results of an activity. It reduces errors. And a very unappreciated aspect of automation is it makes processes explicit and versionable, by which I mean, when I automate a process, the way it's automated, effectively the code that does the automation, is a description of the process itself. Now, a lot of things that we do, we don't document. We don't have a reliable way of repeating them because it's just something I perform and I have it in my head and I just bang it out on a keyboard. When I automate it, now I have a written description of how it works. Now that description is machine readable because some machine is carrying it out. But that written description, now I know exactly what the process is and I can share it and I can share that knowledge. And I can also version it. In other words, I can say this is the process as of now, this is the last way we did it, and this is the time we did it before. And even more important, I can take those processes that have something to do with a specific application, like how do I build the widget application? And I can keep it along with the source code, which is versioned. So my version 1.0 source code has the build process. And when I have a version 1.1 set of source code, which is a slightly different build process because I have a different, maybe I added a module, that's versioned along with it. So I can associate the process with the way the software was at a particular instant in time. Now that's kind of an underappreciated value, but it's a huge deal. It's important to understand that automation is not a goal. It's a means to an end. We don't automate everything and we don't want to automate bad things. It's simply a tool. And it's a tool that requires an understanding of the end-to-end process. It requires an understanding of the process we're automating, but also the bigger value stream, the meta process, if you will, that our process is embedded in. Because ultimately, our piece of automation is going to become part of a larger piece of automation. So, sorry, there's a question here. Okay, good. So I have a question. This is a good question. Arturo, thank you. How to, and this is a little bit more related to culture, but this came in afterwards. How to empower a team with shared accountability using DevOps. That's a deep one. Okay, so there's no magic fairy dust that you can just sprinkle on a team to make them change their attitudes, to make them change how they work. So empowering a team, giving them shared accountability. I mean, that's a potentially huge topic on itself, and it varies a lot depending on the nature and culture of your particular organization as well. So there isn't going to be a single answer, but there are a few things that that are common to how you start making that happen. Part of how you make that happen, how you empower that team with a shared accountability, is you assemble a team that actually has individuals from across the entire DevOps process. So one way you establish shared accountability is instead of having a team of dev people and a team of ops people and a team of security people who all have their own effectively siloed accountability, you bring those people together on a project basis or product basis. Hey, all of you people, you're responsible for the widget application. Then what you do is you start talking that culture. Start talking about what are the kind of end goals. Instead of, well, we want to get the defect rate out of our build failure rate in development below this number. Start worrying about those pieces of the end product. So when I'm speaking about something like what's our how long it takes to move something into production, say, that overall cycle from coding to release, deployment, that becomes a conversation about what everybody does to promote that. And another piece of shared accountability is to have people understand how what they do affects other people. If, for example, there's something that we're doing in development that requires a bunch of kind of complicated things to happen in operations when we're actually putting something into a production environment, we should bring that out, make that explicit. And you may not be able to solve it right away, but that shared accountability starts to be, the developers understand maybe they need to refactor their application to be able to make it easier to actually deploy. And if we're having that conversation always around how do we minimize that overall cycle time for the entire end-to-end process, that helps encourage that shared accountability. And I think one could go on, but I think the last thing that I'll say about this is this kind of shared accountability across a team. I don't know how that can happen organically. That in other words, I don't know how that can just kind of spring into being in a team unless management supports that, unless management explicitly supports the notion that it's the team's output that's important, not so much the individual output. And in many organizations, there's a kind of organizational conflict around this. If I manage a dev team, say, how do I do the performance reviews? How do I kind of reward them for their activities? Typically, what they're rewarded for is things like productivity. Are they doing the right thing from business point of view? Whatever it is, there are things that are about development. They're not about other things. Over time, this is not something I'd expect anybody to change magically. Over time, you want to see the reward systems in the organization start to shift away from departmental objectives and towards cross-functional team organizational objectives. That may be one of the really powerful ways of encouraging that shared accountability. And honestly, it's a little hard to see how you can go really, really far with shared accountability unless the organizational reward systems are in alignment with that. So thank you. That's a really good question. There's another piece. There's another good one, Diane. Nice. What's the difference between infrastructure DevOps, infrastructure as code, and traditional app DevOps? I don't know. You tell me. Keep in mind, I'm not being flippant. Keep in mind, there isn't a formal definition of DevOps that everybody can agree to. So to me, infrastructure as code is a way of doing things. It's a tactic. And it's a very powerful tactic, but the idea, if you haven't heard the term before, is that you describe in code, in a text file, what you want infrastructure to be like, and you hand it to some machine agent that will read that description and cause that to come into being. And there are a whole bunch of variants on this. Things like configuration management. So I can say, here's a configuration that I'd like a server to be in. Please take care of it for me. All the way to environments, which you can do in something like Amazon or Azure. Say, here's a description of the environment I'd like. Now, please cause it to come into being. And the cloud environment instantiates it for you. Well, the tool does it for you. So infrastructure as code is really this idea that instead of having to manipulate physical infrastructure. We can write a description and have a machine do it for us. Very, very powerful concept. To me, that's not infrastructure DevOps. That's just an enabling technology. Hugely powerful enabling technology, but it's not in and of itself DevOps. Now, you say, what's the difference between infrastructure DevOps and app DevOps? I'm not sure I'd recognize the term application DevOps as a separate thing, but I think what you might be leading to in this question is the idea that in many organizations, DevOps doesn't just spring into being kind of fully formed across an entire organization. Usually it starts either more on the development side or more on the operations infrastructure side. When it starts more on the development side, usually we call that agile development, and we augment it with tools like continuous integration, things like that. When we start on the infrastructure side, we're making use of infrastructure automation tools, tactics like infrastructure as code, and a bunch of other things. And we may extend those processes and wire them together, kind of bring them together. When I talk about end-to-end DevOps or just DevOps, what I mean is an organization that's doing the application side, which would be agile, and they're doing the more operation side, probably making use of things like infrastructure as code, and all the things in between. So I think DevOps isn't really kind of one or the other, but it does tend to start on kind of the early part of the process or the later part of the process, and ultimately kind of meet in the middle. But thanks, that's an interesting question. So I'm going to return to core values here. The third core value in this model, this CAMS model, is measurement. If you can't measure it, you can't improve it. This is Peter Drucker, who is anybody who's gone through business school will have heard of him. He did a lot of the work around quality processes, continuous quality improvement. He didn't do it, but was related to things like the Six Sigma movement. And he had a lot of ideas about how businesses can use measurement and an understanding of process to improve their practices. And that idea that we can measure things and use that to make fact-based decisions is important in DevOps. Now, this thing about measuring all things within reason, bold, emphasize, underline, and italicize within reason. Measure things that are important and measure things that are relatively easy to measure. So I think the take-home message is measurement's important. Don't get hung up on measurement for its own sake. There are a few things that can be important, key performance indicators, that are useful for an organization to determine how effective they are at doing DevOps. And these key performance indicators ideally should be based on what the desired business objective of a DevOps movement is. Again, if my objective to support business is to be able to allow more frequent, smaller changes, one of the key performance indicators I would wish to measure is deployment frequency. How often do we deploy into production? Another one I would want to measure is what's the process time, the in-process time between somebody starting to write code for a function and that function, that capability, showing up in the production environment. Those two metrics together tell us the two things that are most important to business if they're interested in smaller, more frequent releases. How long it takes to get something from not request, but starting to work on the request, out into production, and how often those releases happen. Whatever it is that's important to you, define some key performance indicator, and ideally have tooling that's able to support that. And a lot of the process management tooling is able to do exactly this. Whoops. And the last of the values, at least in this CAMS model, is around sharing. Now, sharing is one of those things that as kids we're all told to share. You're on the schoolyard, you're told to share. It's a culturally difficult thing to be able to do because modern organizations are often organized kind of without a lot of sharing in mind. We have org structures, we have departments, we have implicit barriers between departments, and often we don't have a lot of good mechanisms for actually sharing, even if we want to. If I want to know something, do I know who to go to? Do I have a repository where that can exist? So think about to support this culture, not just kind of making it clear to people that you expect that sharing is a value, but also how do you actually do that? How do you capture knowledge? How do you share knowledge? Who maintains it? And where does it go? Do you have repositories? And I will tell you, some repository, some mechanism that is easy to use, easy to change, allows pretty much anybody to be able to contribute without needing some elaborate process, and exposing that across the entire value stream, kind of everybody in the end-to-end process, and organizing them around product, like my widget application and my spinny thing application. Organizing them around those products will dramatically increase your ability to share. Many of the barriers that organizations face to effective sharing are simply technical. I have a file system, shared file system where I put Word docs in. That's not a good sharing mechanism. I have a SharePoint mechanism that anybody can read, but only a few people could contribute to. Better. I have a wiki like Confluence, the Atlassian product, or pick your tool that anybody can actually edit, and it's organized around product. Wonderful. So support the culture of sharing with technology. Now, I have a question related to measurement. Sorry, we're going back to measurement. I'm picking up the questions a little later. Okay, right. Sorry, I had to interpret. So the question is, are we interested in KPIs? Because when they're clearly defined, measured, and reported and shared with others, and they can be seen in context, they shape incentives, shape behavior, and shape the culture. Right? Yes, right. Arturo, absolutely right. The purpose of the KPI is to be able to state what the organization feels is important. The reason we're showing it as a KPI is because we feel it's important. And the fact that we've shown it as a KPI, a key performance indicator, implicitly says this is something everybody's to work towards. If I have a KPI that says I want a higher deployment frequency, I was X and I want to be Y, that's a message to people that we expect that that's where we're trying to go. And yes, it shapes behavior, it shapes culture. It should shape incentives. In an ideal world, incentives would be tied to those KPIs that are important. Your question, though, Arturo, it's a very good question, but it raises a kind of another point. And this is part of why we want to be careful what we measure and what we kind of publish. A KPI, a key performance indicator in business speak, is something that is intended to have the effect that you are suggesting. It's intended to send a message, and it's intended to influence behavior. There are a lot of other things that we might measure that we don't want people to take in that same way. I want to measure something because it helps me understand a process or improve a process or keep an eye on a process so it doesn't go out of control. I don't want to kind of have people kind of staying up at night thinking about how they can change a particular number from 3 to 4 for one of those measurements. Sometimes measurement is just a tool. And that's one of the reasons that we actually use this term KPI, to distinguish those things that we measure that are important to us, but for another reason, from those things that are really the key performance indicator that are intended to send the message and drive behavior. So yes, good insight. Thank you. These core values, CAMs, they depend on communication. And communication is often a challenge in an organization. Modern organizations are usually organized in silos. I mean, classic organizations. An org chart is intended to divide functionality up, divide responsibilities up. So we're organized in silos. We may be divided by physical location. We have different concerns and priorities. And there's this other thing. Formal communication mechanisms like change requests and stage gates, and service tickets and things like that. Those formal mechanisms are things that they're not just about communication. They're about the company's culture. And usually they're there for very, very good reasons, but they solve problems in ways that often get in the way of effective uh, low friction processes, such as we're trying to develop in DevOps. Now, how we deal with that, kind of bigger topic, but recognize this kind of thing is a challenge and sometimes a barrier to communication. So how do we improve communication? There isn't a set answer. There's no magic fairy dust, but the more frequent and the more casual that interaction is, the better it will work. The more communication is about goals and collaboration and less about than it is about here's my set of formal responsibility, the more effective it will be. And an underappreciated part of this is how important it is to match tools and the mechanisms for communication with the culture of the group and the nature of the organization. If you have a small organization that is physically located in one place, tools often get in the way. Having a meeting, a daily stand-up, really important, critical piece of communication. If you have a large distributed team, may not work quite as well, but having mechanisms like video conference, Slack, tools like that could be very important. Again, matching the culture of the organization and the people in the organization is important. I'm kind of old school. I really like email, but in a lot of organizations, that's not a great way of actually communicating. Instant message, tools like Slack tend to be much better. It really depends. And never underappreciate the value of tools that have multiple purposes. So something like Jira as a mechanism for kind of managing a Kanban board associated with a project. That's a communications tool. And picking the right tooling that facilitate communications, right for the group and right for the circumstances, hugely, hugely valuable. The core values, CAMs, also depend on collaboration. Okay, now I'm not going to talk about all these points, but some of these things. We're interested in collaboration, not as a just I'm going to collaborate with those kind of in front of me and behind me in an overall process. We want this entire life cycle from starting to code to running in production as a single end-to-end process. Now, that end-to-end process doesn't have to be literally one process. That end-to-end process can be assembled or composed of a bunch of more focused, more specific processes. It's not on the slides, but that's actually why I've been using the term value chain. When I talk about value chain, what I mean is that set of activities that are composed together, that they're a sequence of activities that delivers value. And that value chain is, it starts with starting to code and it ends with something running in production. That value chain is assembled from a bunch of smaller focused processes, usually. And it makes sense to do that because different parts of that value chain have different emphases in what they're concerned about. Usually that's agile as that kind of sub-process, if you will, for the software development piece. And then perhaps something like ITIL, Information Technology Infrastructure Library, for deployment and operations. Now, I know all your mics are blocked, but I can visualize in my head. I say ITIL and everybody goes, it's gotten a bad name lately. ITIL is actually a really good framework for thinking about how an information technology organization can manage the processes they need to carry out, including things like deployment and running things in operations and change management and all those pieces. And if you can kind of get away from the fact that ITIL sounds like it was written for a previous generation, for kind of old school enterprise, which it was, it doesn't mean that the ideas in it aren't good. ITIL is actually a really good resource. So close your jaws, it's okay. To the extent that we can, we want to support collaboration with unified tooling. In other words, to the extent that it's practical, I want to have one set of tooling across the entire value chain. An example of that is something like Jenkins or GoCD for continuous integration and delivery. It's a tool that can run right across from I've checked in some code and I want to build it and test it, all the way to driving that code into a production environment. So Jenkins, GoCD, tools like it, excellent unified tool to support collaboration because we have one set of tooling pretty much everywhere. Infrastructure as code tools like Puppet, Chef, or whatever are tools that allow us to be able to manage configuration early on in the process, shift left, and cause it to come into being later in the process. One tool across the value chain. I think maybe one of the most important things, I think the last one that I'll touch on here, a single knowledge repository across the entire process. To the extent that you can, have that Confluence Wiki, whatever it is, to be able to have one place where all the information about the product actually goes. So, given all of this can be kind of overwhelming, there are a few behavioral patterns that we would encourage and we'd hope to see in people to be able to drive DevOps success. Well, we might label these the 7 habits of highly effective DevOps experts, because in this model there are 7 of them. And this all goes to how we develop these behavioral patterns in people. Well, we start from culture. The culture drives how people work. The people drive the process they use, and the process should drive the selection of the tools. And what are these 7 habits? Automation, shift left, transparency, standardization. Now, I haven't talked about that yet. Standardization is simply the behavioral pattern that, to the extent we can, we would prefer to have a smaller number of choices than a larger number of choices. We would prefer to have one way that servers are built. We would prefer to have one build process. So we try to drive standardization both across the value chain and across the organization. Not to the point where we restrict people's ability to do things. There are places where variation is useful. But if variation in and of itself does not add value, we should try to drive it out. Compliance. So compliance, we also haven't talked about yet. Compliance is this idea that we have a bunch of kind of 2 related ideas. One idea is there are some kind of principles and practices that we expect teams to conform to, and these are kind of standards that we'll follow, and that compliance helps the organization overall. And there's a balance between flexibility to be able to give teams the ability to adapt to their particular product requirements, and compliance objectives across the organization. The other form of compliance is the more formal compliance across an organization, governance processes. Compliance requirements, often many of you will be in regulated environments like finance or healthcare. And there are a bunch of compliance things that you must do. And bringing those into the habits, one of those 7 habits, an understanding of what the compliance requirements are, and building processes and applications with those compliance objectives in mind is important. There aren't a lot of things that are more difficult than taking an application that you've already built and trying to retrofit it for some compliance objective. And knowledge objectives, knowledge sharing and collaboration we've talked about. I have a chat message. This is beautiful. So I have a question. What team topologies are more convenient to leverage collaboration? Well, that might as well just be a lead-in into my next slide. What are DevOps org structures? So there are a whole bunch of different ways that we can organize a DevOps team. And this is another area where the way that you do this should really depend on the organization that you're in. And a lot of it depends on the shape and nature of the organization. I used to work for a small organization. We were about 30 people. And we had a dev team of, I think it was about 11 people. And we had effectively one team. We did everything. And this was before DevOps was a popular term, but I look back at what we did, and we were doing DevOps. And part of the reason that we was because we didn't know any better. This was really the only way that we could effectively take our really small IT organization and meet the very demanding business objectives for release frequency and quality and all those things. We had everybody do everything in a very controlled manner. So that fit for that particular organization. A very large organization, particularly a regulated organization, I do a lot of work with the banks, for example, they can't do that. or they're not going to in any reasonable period of time, and nor should they. They have a different kind of structure and different sets of objectives. So the org structure that you create for DevOps will depend a lot on what the organization is like. On one level, DevOps is about bringing development and operations together. And it's a little unfortunate it's called DevOps because that kind of implies there aren't other organizations. It's other people too, other stakeholders, QA, security, compliance, whatever happens to be right in your organization. It's assembling those people into a cross-functional team. Over time, many organizations will start to think about, well, do I actually start to kind of merge some of those together formally in an org structure? Start doing things like having development overlap with operations. We might potentially merge development with operations. In many organizations, there's some pluses and minuses to that. There's another aspect to what the org structure should be like, and our course on this goes into considerably more detail. But another aspect of an appropriate org structure is what's the nature of the organization? Are you product focused or are you project focused? Here's what I mean. A product focused organization is one where I have a product and that product is continually evolving, and I want to have a team of people who are kind of dedicated to that continual evolution of this product. And that product has no real end in mind, in the sense that I have this thing and I'm expecting it to evolve kind of for this foreseeable future. Now, if I'm a company where I'm delivering effectively software as a service, that software is my product. And a product focus is kind of an obvious thing if I'm Salesforce or Spotify or, pick your equivalent. I might, if I'm a relatively progressive kind of bricks and mortar enterprise, I might be thinking around product around specific things. So if I were in a bank, say, I might say the customer facing interface, web interface, that's a product. And I have a dedicated team, and I'm evolving it forever. A project-based organization, this is more common in enterprise IT, is one where we decide as an organization what we're going to implement a new warehouse management system. And I'm going to assemble a project team, and I'm going to say, hey team, you're going to be working together for the next 6 months, and your job is to take the warehouse management system from version 1.1 to version 1.2, or go implement this COTS product, or whatever it happens to be. And what will happen is you have the project team work, they finish, and then they're done. They disband. The project's over. People go on to something else. The project ceases to exist from an organization point of view. And that has a kind of different nature for how you assemble an org structure for project-based organizations, because they're kind of assembled for a period of time, they got rid of, that it doesn't really have a natural place to connect together the development activities and the long-term operations activities. Implementation, sure, but long-term, so you tend to have a bit of a different structure. It is a good idea, a very good idea, to be aware of, and this is not on the slide, the difference between the org structure as it's shown in the org chart, as you'd see from HR, and the structure of a virtual team, a cross-functional team. If you take the approach that and this is very common in project-based organizations, we're going to assemble a cross-functional team which cuts across a bunch of different parts of the org chart. And now effectively the people on that team, they've got kind of two masters. There's the master that they have on the org chart, and there's the master that they have within the project team. And that can be confusing. It can be confusing for communications, it can be confusing for incentives. And being aware of that is an important piece. It is a very, very good idea to start experimenting with your DevOps organization, however you decide to realize it, through a proof of concept or pilot team or a tiger team or whatever it is you want to call it, who takes on some project of medium risk and medium priority to gain experience with DevOps and something that's safe enough that you're pretty much sure you're going to succeed, so you get a tactical win. And on this note, you want to be doing this in an environment where the project is important enough to matter, but not so important that all eyes are going to be on it and it's going to be a total disaster if you like cause 4 hours delay. So, question here. As an organization creates more DevOps teams, is there a method for organizing solutions and products at a higher portfolio or enterprise level? Yeah, that's an interesting question. I think there is, and I don't think this is so much a DevOps thing. I think this is more kind of portfolio management thing, and an enterprise architecture thing. So this isn't going to be a complete answer, and this is not really my thing. So I don't have deep insight into this. Part of this is going to be around things like organizing solutions and products, and a piece of this is going to be if I have more and more DevOps teams. What level of collaboration do I want between them, and what level of standardization of tooling and methods do I want? And that's really kind of a governance standardization thing. How far do you want to go with letting teams select their own products? How much do you want to encourage teams to kind of use a common set of standard things? And I've seen this play out a number of ways. I've seen organizations that have said, we're going to avoid this problem by dictating what the standards are, and that's really sub-optimized some teams. Okay, sad. I've seen the other side though. I've seen a major Canadian organization which has basically said, we want to get everybody on DevOps fast. We don't know what the right answer is, so we're basically going to let everybody. We're going to let teams self-assemble, and we're going to let them pick their own tooling. And they have an environment where what's starting to emerge is a bunch of tooling that's completely redundant. So they'll use tool A in one team and tool B in another. They're incompatible tools from different vendors who do the same thing. And I'm not going to say that's right or wrong. I'm going to say that my observation is they're moving forward pretty quickly, but they're going to have a problem cleaning this up later. When it comes to managing the results of DevOps, the products, the software applications they're building, to me, honestly, that's not a DevOps problem. That's a portfolio management problem. And when I say problem, it's a portfolio management challenge. Portfolio management is a well understood thing to manage inside enterprise IT, and I don't think that DevOps, in my opinion at least, DevOps really does anything one way or the other to the notion of portfolio management. Another comment. One person just thought about this. Does operations mean IT operations or business operations or both? Well, I got to be honest. When I'm talking about operations, I'm speaking of what we classically call IT operations. I was not thinking of business operations. Yeah, I mean IT operations. So put it this way. Just one last thought on org structures. Just for clarity, doing DevOps does not automatically require that you change your org chart. An organization may want to do that one day, but DevOps teams can be virtual. They can be composed of people from various parts of the org chart, and they can still be perfectly effective as long as they work well together. So DevOps org structures does not necessarily mean you need to start shuffling the org chart around. Most people don't. Okay, now I'm going to talk about a topic that's actually setting us up for the next chapter, and it's starting to get a little bit more into the guts of how DevOps actually happens, and it's this topic: continuous delivery. So continuous delivery is a practice. It is a practice, or this calls it a software development discipline, where I build software in such a way that the software can be released to production at any time. Now that's a definition that Martin Fowler has given. And I think that definition is true, but it's a little bit, you have to read between the lines to understand what it really means. Here's another way of saying continuous delivery. Continuous delivery is a practice in which you automate the process by which you build, test, and deploy software, such that that software can be released to production at pretty much any time, at your choice. And the way it works is you automate enough of the process that there's effectively no marginal cost to delivering the software into production. In other words, if I really wanted to, I could say, as soon as somebody changes some code and checks it into a source code repository, I can build, test, and assuming the tests work, deploy the software into production with no human intervention. That would be kind of the ultimate expression of continuous delivery. Now, don't get scared by that. Almost nobody actually does that, and for very good reasons. But having something that could do that is tremendously valuable. And it plays into this notion of DevOps, and in particular, continuous delivery, that we want to be able to create a repeatable, reliable, and agile software development lifecycle, delivery lifecycle, that extends right from ideation to delivery to the client. Now, I have a slight problem with the word ideation. Ideation means I've thought of something. We can't automate that part of it. So to me, continuous delivery, it starts when somebody's written some code and they check it in. But you know, that's a small hair to split, but it's a bit important. Why do I do continuous delivery? Well, part of it's about agility and repeatability. If I can press a button and deliver my product, that makes me tremendously more agile. It allows me to break my units of change into much smaller pieces. Repeatability means that I have some assurance in the quality of the process. And it's sustainable in the sense that it's giving me this process that I can build on over time. It depends on this concept called a deployment pipeline. Now, a deployment pipeline is really just a jargon term for the automation around the deployment process. It's a mechanism, a means to an end for continuous delivery. And a deployment pipeline, this automation, is typically a set of tasks that are broken up into what we'll usually call stages. And at each of those stages, they kind of mean something. At each stage, we're implementing testing, and we're implementing some controls that kind of allow us to intervene in the process. Because that description that I gave earlier of change automatically flowing into production just by magic, usually that we don't do that automatically. Usually what happens is we want change to kind of move through a bunch of stages, including things like UAT. And then we make a decision whether we want to actually release into production. But that's really just pushing the button. Yes, it's okay. This notion of a deployment pipeline really shifts left a lot of the activities that we'd normally think of as downstream activities, and we're describing them early on in the automation process, which we version along with software. And we know that some characteristics of organizations that are doing continuous delivery. The software is deployable throughout its life cycle. In other words, I can pretty much deploy the software whenever I want. Now, that doesn't mean that I do. I may have just brought up the software to be able to do hello world, but you know, in principle, I could deploy it. An organization is focused on continuous delivery if the first priority of the team is to be able to make sure it's deployable. That if something happens, if I do something to threaten its ability to deploy, I break the build in jargon, that I drop everything and I fix that before I add new features. That deployability is an important property. That we get automated feedback of the process, and that we can cause deployments by some mechanism, pushing a button or triggering something on request to environments. Yes, got the note. Very shortly, yes. Oops. Now we're getting very close to breaking here. So. Now there's a related process, and it's really the first stage of continuous delivery, and it's continuous integration. The continuous integration is a software development practice where a team integrates and tests their work frequently. In other words, as people are working on code, a team, which might consist of several developers, as they're completing sections of their code, they're going to integrate what they've written with whatever everybody else is doing, and they're going to test. And each person integrates frequently. The slide says daily, it's usually more than that. And every time that integration happens, there's an automated build. And if the build breaks, if you discover some issue, you focus on fixing it before you move on. And what happens is this notion of continuous integration means that developers are getting immediate feedback whether there's an issue. And you get immediate feedback on whether something has caused problems in the software that allows you to fix those issues. We tend to have an environment then that has much higher quality. It has higher quality because we discover defects early and we fix them early. We don't have kind of a pile on of defects. And we tend to have an environment then where we have much less issues when we actually go to integrate and deploy that software. Because when we go to deploy it, we've already built and tested it over and over again. So what continuous integration looks like is a sequence of activities that's pretty much we build the software, do whatever it takes to turn it into turn our source code into executable artifacts. And when we're building that software, a critical aspect of continuous integration is that we take the entire product. So if I have one developer, Mary, and she's working on a component, and she checks in some code related to that component, the entire product, not just her component, is all built. It's all kind of turned into an executable artifact, and then we test it. We do unit testing, we do integration testing, we do smoke testing, whatever automated testing we've built up over time. Now, the rest of this slide talks about progress through environments, and that's actually CD, so it actually shouldn't be on this slide. These methodologies enable automation of the build really early on. They start to shift left the activity of getting server environments, deployment environments ready and starting making use of them. It encourages us to actually do testing on environments that are similar to production. In an ideal world, in a totally ideal world, what would happen as part of the continuous integration process, we would actually spin up an environment that's production-like, use it for a short period of time to do our testing, and then throw it away. It turns out that continuous integration in particular, and to a more general extent continuous delivery, support the agile methodology. If you're doing agile software development, you get immediate feedback through continuous integration, and that's critical to agile. I had prepared for this ahead of time, and I had sitting in my lunch delivery pipeline a ham sandwich, so recharged and ready to move on. And we're going to move on with we're going to talk about starting up DevOps practice. So in this section, we'll talk a little bit about the impact on the enterprise, how we fit into the enterprise, some governance issues we need to be concerned about, and how to think about the techniques, practices, and metrics that we'll use around DevOps. And a key part of this idea of DevOps, starting up DevOps practices, is to recognize that there is no standard formula for starting up DevOps capabilities inside an organization. Every organization finds its own way of doing DevOps, and that the slide talks about that in terms of organizational forms, but it's actually bigger than that. It's not just what's the right organizational structure, it's also what's the right path to DevOps, what works inside the organization, and it depends very much on what your culture is, who the people are, what the motivations are, kind of where you want to go. And this idea that there's this idea that we're going to talk about a way that we can stand up DevOps, take everything that we talk about in this chapter as suggestions, a bunch of ideas, and not some gospel method. There's certainly a number of things that we want to look for and try and avoid. Some of the things that can go wrong in starting up DevOps practices inside an organization are having the wrong people or wrong processes that may actually cause DevOps to be kind of worse than doing nothing. You turn it into a liability rather than an asset. This notion that the wrong people can cause DevOps initiatives to fail is simply because think of all those cultural things that we talked about in the last chapter. If you don't have the people who are adaptable to that kind of culture in time, not out of the gate, because we generally don't have that culture to start with. If you have people who can't get there and they really resist it, it can actually be quite significantly detrimental. Now, another thing to be very careful about is you have this idea that DevOps is about cooperation and community and sharing of responsibility. That does not mean that we should go ahead and break down some of the barriers, some of the separation of duties that exist for very good reasons. We want to, despite the fact that we have a team that has a set of common objectives, have some discrete roles. Some of those are very, very simple things, like just because we have a DevOps team with shared responsibility doesn't mean we should give credentials to the production environment to everybody. Now, this is wrong on a whole bunch of levels. One thing that's wrong about it is any decent control, any decent governance is going to tell you you can't do that sort of thing. But even aside from that, you can have issues where developers can just slip things into production just because they feel that they have some need to. Despite the fact that we talk about process and automating process, it doesn't mean that people will do things the right time, the right thing all the time. We should be having environments that that separate some of the not only responsibilities but control mechanisms. Keep supporting documentation in a version control system. Keep automation scripts. All those things should be managed properly, and production credentials managed in a way that only authorized people can actually make use of them. An enabler of good DevOps practices inside an organization is the idea that we think about the ownership of assets. So think about what happens when there's some asset that isn't really owned by anybody. Well, there's a famous paper, Tragedy of the Commons, that describes this case. Essentially, the nature of this is if you have an asset that nobody is responsible for, everybody will exploit it and nobody will take care of it. And unfortunately, inside enterprises, this often happens to systems. So having some concept of ownership of applications, indeed, ownership of tools, ownership of processes, will be critical to DevOps. It brings notions of accountability to the organization. It brings the ability to evolve product alongside with changing needs. It motivates people to actually invest in maintenance and support. And it encourages people to think about quality. This is essentially what's an enabler of this notion that we have shared accountability. The notion that we own the asset is important. Another related enabler is to viewing applications as products, not projects. Now, I touched on this before. If we have a notion that there's a product like the widget application, and that widget application is something that we want to maintain and take care of for an extended period of time, we have for a foreseeable future. We have a team of people who are dedicated to it. We have a sense of what its evolution is over time. And we have people who, when they touch something for it, when they do something with it, they have a sense of responsibility for it. The idea that you built it, you run it. This product model leads to a feeling of ownership of the application and ownership of the process and ownership of the end product, the actual result, that contributes to improved quality. And it tends to produce results. It tends to produce a sense of responsibility that's hugely beneficial. It also tends to be much better at preserving knowledge around something, whereas a project mentality, I work on its release and then I disband the team, has all kinds of other negative implications that are hard to overcome. But perhaps one of the most important of those implications is the lack of sense of ownership. This change in values from projects to products can be a very, very hard thing for an organization. And it can have organizational implications if you're used to having a resource pool that's assigned to projects. And I'm not going to suggest that every organization can just start viewing things as products instead of projects right out of the gate, but it's an important idea. Excuse me. Now, when we think of DevOps in an enterprise, often what we think of is some of those places where DevOps notions were popularized, and largely around web-based organizations. Flickr, Netflix, these places, Spotify, that really live on cloud-based services are really where DevOps came from. And my little story before, but working in that small organization, 7 or 8 people in IT, everybody did everything. We were on AWS, Amazon Web Services. And so when I look back at that, I think what we now call DevOps practices emerged naturally from that model because of the environment that we were in and the fact that we were fairly small. But over time, these notions of DevOps are increasingly becoming common in the enterprise space, and they need to be thought of as a true enterprise capability and put under control of existing governance processes. We have these DevOps practices that are being embraced increasingly inside organizations to help them become more efficient and effectively manage delivery schedules. But in addition to desirable outcomes like higher delivery velocity, more predictable application development life cycles, we also see organizations needing to manage an environment where they have much more frequent small changes. And to be able to effectively make use of these capabilities, we often need some changes in the way that we think about things in the organizational culture to be able to fully realize the benefits of DevOps. And part of that challenge, but also benefit, is in how governance works with DevOps. So governance is the mechanism by which an organization makes sure that they are doing the things that they want to do. And IT governance is about managing IT resources and applications and ensuring that the decisions that we make as IT professionals are aligned with the strategic and operational business requirements of the organization. DevOps is just another process that needs to be managed under a governance framework. So these governance processes, IT governance processes, exist because we need to be able to mitigate IT risks, increase the predictability of outcomes, measure performance, promote standards and best practices. And what will happen as we start to develop DevOps practices is these governance activities will become necessary, that if we don't have them in place, we have no assurance that we have mechanisms to mitigate risk, and DevOps can be a significant risk. But there's a flip side of this. And the flip side of this is a lot of pre-existing, and this is not on the slide, but a lot of pre-existing governance processes are designed for an environment where the need to mitigate risk, the need to manage risk, increase predictability is in an environment where we're making a small number of very, very large and extremely scary changes. And so the processes we develop in governance are intended to manage that environment, and they tend to be heavyweight processes that are expected to be done relatively infrequently and against projects where there's a very high level of uncertainty. And that's very different than what happens in DevOps. In DevOps, we have this notion of risk that's very different. We have in DevOps much smaller but more frequent changes. And risk is significantly decreased because the change is small. We also, relatively small. We also have a significantly decreased risk profile because in a mature DevOps environment, the way that we deploy something is something we've automated over and over and over again before. And because it's automated, there isn't much different that's going to happen in production. So the level of oversight that's required tends to be considerably less. So we still need to be concerned about governance processes and risk mitigation in a DevOps environment. In fact, it's a huge mistake to think that we can ignore these things completely. But classic kind of legacy governance processes tend to get in the way, honestly, of effective DevOps, because they tend to try and inject a whole bunch of control over something that just has a totally different risk profile than what was originally designed for. So understand that that's one of the things that you typically run into. With that as background, how does an organization potentially start a DevOps activity? Well, there are a whole bunch of different frameworks. There are many different frameworks by which you could start DevOps. The simplest and kind of most organic is not on the slide at all. It's simply just start doing it. inside a team, inside a project. Just start doing it and kind of grow out from there. But we need to be a little bit more formal than that for an enterprise. And the framework that I have here is a set of adoption steps that's oriented towards an enterprise which makes a decision that we as the enterprise, Acme Co., wish to adopt DevOps because we recognize that there are some business benefits to it. Now what do we do? And we start by identifying business drivers. I made this point before. The reason that we do this is not because we're technologists and want to improve our technology or because we want to play with fun toys, even though they are fun toys. We want to be able to affect business change. So what business change do we want to affect? So what's our business driver? Then, understanding what our business need is, get educated, learn a little bit of a background, figure out what some of the concepts are and the big ideas. Because I need to be able to have that to be able to articulate a DevOps value proposition. And when I say articulate DevOps value proposition, what I mean is that I need to be able to go to those that need to be convinced, the stakeholders, and be able to say, this is what we want to do. This is why this is important. Based on that, we can define a few scenarios where we would describe software delivery DevOps techniques, which is really, here's how we would actually fit it into our environment. And it might be hypothetical, it might be, here's what we would do if we move forward with DevOps in this environment and that environment. It would be great if you could actually run a small proof of concept. But whether you can or not, it's important to recognize that in a large enterprise, there are typically a few different scenarios for software delivery with DevOps. That we don't do things the same way everywhere. And defining these scenarios will help us understand what the scope is and also what it will look like in particular areas. As an aside, it's common to see organizations that say we can apply DevOps here but not there. For example, in a mainframe environment, a host environment, there's no technical reason why you can't do a lot of these DevOps things. Automation tooling typically isn't in the same place. But often in that environment, we have a situation where we have a well-established practice and we have a set of tooling that's in place and there just isn't sufficient motivation to change it. And the role of that kind of machine is changing in enterprises anyway. So often what we'll do is we'll do DevOps kind of around that environment. After we define these scenarios, we can provide a roadmap, which is essentially a plan. What would this look like over time as we try to roll this out? This gives us the capability to kind of estimate what's required, but also be much more concrete about what the impacts are, which is essential for gaining stakeholder buy-in. Stakeholder buy-in is a critical part of this adoption process. And by stakeholders, I mean anybody who's really significantly impacted by or has a decision-making role in approving the activity. On one level, we could say stakeholders are just those that I need to get sign-off in order to get the authority and funding to go ahead. But a kind of bigger picture here would be to start working with the people who are actually going to be affected, development teams say, and get their buy-in as well. We really want to make sure that we have people understanding, maybe not completely agreed to, but understanding and kind of permitting us to move forward because there are going to be some significant changes. To manage some of those significant changes, make sure that we establish governance. Now, in practice, kind of as an aside, what I see as a bigger issue here is not establishing governance, but figuring out how to adapt existing governance to the DevOps process. And recognize that as a practical matter, it's usually necessary to kind of live with existing governance processes, even though they're usually too heavyweight, and over time adapt them. Rather than expecting that right out of the gate, we're going to be able to get people to agree to change governance processes. From there, we can establish a core team. That core team, depending on how you're doing this, can be the first team who's actually doing DevOps, or it could be essentially creating center of excellence or kind of contact group, whatever it happens to be. If necessary, invest in infrastructure. Now, the slide says not applicable if you operate in the cloud, meaning you can just add infrastructure. What they mean is you may need to add kind of servers. In reality, This is usually software, and there's very little capital investment required. This is not an expensive kind of thing. And finally, pilot, try it out, tweak a little bit, then do an enterprise rollout. Now, this process, as described, is admittedly aimed at a kind of top-down adoption process for a large enterprise, but you can think of it as a framework and adapt the pieces that make sense for you. I have a question here I just want to check on. In this adoption step, when is quality assurance emphasized? Excellent question. So quality QA isn't discussed as part of this DevOps adoption because QA, it's not part of the adoption steps. It's part of DevOps itself. I mean, it's core to, it's one of the core things. If you have an organization where a QA department is a separate org unit, like there's a QA group, then that group is one of the stakeholders in the overall DevOps process. They have to be part of that virtual team that's part of the product, and they have to be part of that overall value chain. So QA is very much a part of that overall activity. And so they're simply not mentioned here because this is about how you get up DevOps started. QA it's part of DevOps. That's a further example of why it's actually a little unfortunate that it's called DevOps. It's called that for historical reasons, rather than something a little bit broader, because it sounds like it's only development and operations. No, it's all kinds of things. But when you start including all the people who are supposed to be included, it gets silly. Like you get like DevSec, QA, whatever, this, that, and the other thing ops. So QA is very, very much in there. Now, some techniques or some practices and techniques you need to be concerned about. There are a number of various common techniques and practices that are important, and there are a bunch of them that are mentioned in here. And I'm going to touch on some of them here and there, and because they're expanded on the following slides, I'm just going to touch on the things that I think are really critical on the following slides. Excuse me, simply because I want to edit for time here. And one of those things that's an absolutely critical technique, practice, continuous testing of all aspects of the application delivery pipeline. Okay, this one should be underlined and extra bolded and have little fireworks going off around it. Automated testing of activities in the delivery pipeline, from building the software, doing unit testing, doing integration testing, testing a deployment once it's gone to a UAT environment, all those things, absolutely, absolutely critical. We're going to have a very heavy emphasis on automation of testing so that we can detect issues early, and we want the testing automated so that we can repeat that testing over and over again. There's a caveat, and that caveat is actually related to the question that was before, but where's QA? In many organizations, there's a test group or UAT group who are a separate part of the organization, and they do what I'm going to call manual testing of an application. They sit down at a keyboard and they move the mouse around. That does not go away in DevOps. There are things that human testers can do, particularly with user interfaces, that you can't automate because we can't automate all the wacky things that people do. Their role changes somewhat, though, because we want to take as much of their kind of regular, that kind of dull regression test stuff and automate that we can. But we do not remove people from the process. In almost all organizations, we do not remove people from the process because people do something that software can't. Okay, so continuous testing of all aspects of the delivery pipeline, key practice. Another key practice, use of version control. Now, if you're developing code, you're using version control. If you're not, you shouldn't be coding. But we're going to extend that notion, and we're going to make use of version control in other places too, like managing the deployment scripts, like managing environmental information about the environment. We're going to try and bring as much as we can under version control so that we can have a consistent way of kind of understanding the state of not our piece of software, but the software and how we deploy it and what environments it's deployed into. So version control everywhere. Having a defect tracking system is also a very, very valuable practice. Now, most organizations have something like this. Don't care what it is, but some mechanism for kind of managing defects and issues is a really good practice because it makes sure you don't drop things, and it's a great tool for sharing across the extended team. And to extend that notion a little bit more, having one tool that manages both your backlog and your defects is usually considered to be a good idea. Something like Jira, or pick your tool. Jira is kind of a classic, but you can pick your tool. Yeah, I'm gonna. I see a question that's a really interesting question. I'm going to come back to that right at the end. Here. Iterative and frequent integration and deployment. That's continuous integration. Enough said. Oops. And automation. Also enough said. It's going to sit kind of underneath all the other processes, and it's critical. And this last thing that I'm going to talk about here, change management. So change management, not configuration management, but change management, the kind of classical process of managing change in the organization. People often forget about this piece, but it's an important part of DevOps. So having mechanisms to kind of formally manage change, make people aware of change, kind of make change auditable, are all important for supporting a DevOps process. Now, I had an interesting question, and I'm sorry, I have to pull it back up here. Here we go. So there's a really interesting question. Is it possible to implement DevOps in an organization where the infrastructure group is from another department and the application is from a vendor? Yes, of course. But it may look a little bit different. I don't see a significant problem with the infrastructure group being in another department. That's super common, happens all the time. The vendor thing's a little different. And I run into vendor issues all the time. And it's very common. And I don't have a magic way of kind of making COTS packages, commercial off-the-shelf packages, feel like they're software that we build, because we don't build them. So opinion differs on this, but my reality around COTS packages are that there's certain things that you can do and certain things that aren't practical. That from a DevOps point of view, we want to automate the stuff around the package. But my experience with commercial packages is usually infrequent releases. There's often a systems integrator, third party, involved in a big release. They're treated like projects. And so we don't get the chance to really integrate our DevOps processes during an integration. An SI, generally you can't interface in that way because they have their set of practices, they're contracted to do a particular thing, and they'll do it. Okay. That doesn't mean that we can't do a lot of DevOps stuff around the edges that's valuable. But at some point, often we treat that vendor package as a big monolith. Now, that doesn't mean that we can't have some practices around things like, can we, for example, apply vendor patches more frequently so we can increase effectively deployment of change in that package? Yeah, that may be a practical thing to do. It kind of depends. I have a client who's on SAP, some SAP systems, and there are certain things we can deploy frequently and certain things that we can't. And things we can't because they cause behavioral changes in the application. And so from a business point of view, there's things we do and things we can't. Vendor packages, definitely an issue. Not the end of the world, but definitely an issue. There's another question here. Yeah, there's a little bit more development to this idea of an organization that has separate infrastructure. Yeah, and so without kind of repeating all of this, you will. I have run into situations. I see this in government. I see this in the Ontario government. I heard this in the U.S. federal government in places, but I have some direct experience with it with the Ontario government, where there's an organization that provides all the infrastructure services, and they're really totally arm's length from what's effectively the business. In that particular case, the situation I'm thinking of, the The IT organization has been very successful in doing the kind of early stuff, which is really around agile and continuous integration, and they have some automated ability to deploy to a certain extent. They have no real control over infrastructure, and they just don't tackle that part of it. And that's unfortunate, but you know, sometimes you just have to live with what you have. Which I guess raises another good point. DevOps, because it's not a thing, you can, it's adaptable to different situations. You may not be able to get full end-to-end control over a process, that full end-to-end value chain, but you may get significant business value from those parts that you can control. Similar ideas, most enterprises today, they still own a lot of their own infrastructure, and they don't have dynamic provisioning capability. They don't make it look like a true cloud. And in one sense, that's a limitation. But in another sense, it's just the environment you work in, and you can still get significant value. In all of this, and this is the last slide on standing up DevOps, keep in mind what your business objective is. And just like we talked about KPIs, there are various service level measures that we'll want to think about and keep track of as we're rolling out DevOps processes. And typical ones are things like availability and reliability, resiliency, performance, whatever it happens to be. Personally, availability and reliability, those are kind of direct measures of the stability of the environment that you've created in production. Another useful one that might be valuable is how long it actually takes to do that deployment into production, and whether that deployment into production actually causes a service interruption. Because depending on your application architecture, that deployment may happen without kind of your customers being impacted, or it may actually require that you turn off services for a short period of time. So that's the end of this section on standing up DevOps. In the interest of time, and because I've talked about continuous integration and continuous delivery somewhat already, I'm going to jump ahead. And the place I'm going to jump is into Docker. And so just make a note here. Good. Okay. So you're going to see the slides go by really quickly here. There we go. And what I want to talk about Docker, and I'm just going to touch on some highlights here. I'm going to talk about it because it is becoming an increasingly common part of the way that many organizations think about their build and deploy processes. And as such, it can be a very valuable tool in the DevOps toolkit. It's totally not necessary. Nobody needs to make use of containers. But containers have a really interesting place that supplement a lot of and help enable a lot of the DevOps values that we think are important. So what is Docker? Well, Docker is a class of product that we can broadly term containerization tools. What a container is you could think of it like a virtual machine, in the sense that I can put things inside it, like applications. I can configure it, like I can install a software, like a Java runtime or a package or whatever it happens to be. And I can set environment variables and things like that. So I can configure it just like I could in a normal VM. But it's not a real full virtual machine. It doesn't have its own copy of an operating system. And as such, it's very lightweight. So the hand-wavy way of describing containers is like a virtual machine, but without the operating system. You think, what would that mean? Well, a container doesn't live all by itself. A container is hosted by something else. It's hosted inside an operating system. And effectively what the container does is it shares the host operating system. And what this leads to is a couple of things. Well, first, these containers, they're really, really lightweight, which means I can take a machine and I can run a bunch of containers on it with effectively no real overhead. Now contrast that with a virtual machine. If I were to take a virtual machine and put an operating system on it and run it inside a host, I could do that, and I could take another virtual machine, put an operating system in it, and run it inside that same host. Now I've got two copies of an operating system, full operating systems running inside that machine. That takes up a tremendous amount of resources. It takes a long time to start one of those things up because that's go through a full boot cycle. But it has the advantage of completely isolated what's inside that virtual machine from anything else. And there's a tremendous value in doing that. Well, in the container, I get all the benefits of that isolation, yet there's none of the overhead because the container is sharing the host's operating system. When I go to a container and I say, container, please start, it starts really quickly, really, really quickly. I run a Mac. I have a Mac, and it's a kind of mid-range machine, nothing particularly special about it. I run Ubuntu inside a regular VM, so I've got kind of my host operating system and my VM operating system. Inside that Ubuntu machine, which is already weighed down by all those other things, on my machine it takes 80 milliseconds to start a container. 80 milliseconds, under a tenth of a second. And that's tremendous. These containers, they're also very lightweight in the sense that they don't contain a full operating system, they just contain the things that you put in them. And they're fully isolated, which means anything in a container is isolated from things around them. Now, we'll develop these ideas a little bit more as we go, but that gives you a sense for why this is important. We talk about Docker because Docker is the predominant containerization product in the world today. It's open source, free product. You can purchase support if you want to. That gives you the ability to create and manage these containers. And it is becoming an important part of the DevOps ecosystem because of these properties of containers and because it allows us to start using containers as a mechanism for deployment. Now I'm going to skip over that. Oh, sorry, I should cover at least a bit of this. So Docker, as a specific technology, it depends on a host operating system to run. It primarily runs on Linux. There is a version of Docker for Windows. I'm sorry, I'm trying to get to the question here. There is a version of Docker for Windows as well. And it's starting to, the question, does Docker have any other options apart from Linux? So Docker runs on Windows now as well. Now, there are some limitations, which I'm not really going to get into in depth, but because a container shares its host operating system, a container has to be built for the operating system that's going to host it. So it's not a mechanism for portability across operating systems. It's more portable than you think because a bunch of abstraction layers that are inside Docker, but it's not intended as a tool for allowing, for example, what you don't do is you don't say, I'm going to use this as a way of running some Windows apps and some Unix apps all in the same box. It's not for that. But yes, it is available on other things. Now that said, the slide material, it only talks about Linux, but it is available on a few other things, including Windows. Now the way it works, not going to go into this in depth. This is the Unix view of how it works. It depends on some features inside the kernel, primarily C groups and namespaces. Those are kernel capabilities that allow the operating system to take a bunch of processes, so running software, and do a bunch of smoke and mirrors trickery to it, so that those processes think that they're isolated from all the other processes in the system, and that those processes think that they've got the system to themselves with their own private view of resources, including the file system. And if you really read between the lines in what I said, the effect of that is that the processes think they're in a machine all by themselves. In other words, they think they're in a virtual machine. And effectively, that's kind of what we want. Now, there's a bunch of stuff in here about how it happens in the kernel, which I'm going to skip over. One thing that's important, because this question comes up, you generally do have the ability to manage the resources that containers get. So a common question is, well, if all these containers are sharing the resources of a host operating system, can one of them kind of take all the resources and step on another container? Generally, there are mechanisms to limit the resource use of a container. Just like you can limit the resource use of VM inside a good in a good hypervisor. And there's a little bit here about how it works, which if we had more time, I'd go into. But I want to focus on some of this difference between containers and traditional virtualization. Let me just get a question here. The question, are Dockers effective for bigger or monolithic applications, or are they most effective for microservices? Excellent question, and hold it for a moment. I'm going to come to that in just a couple minutes. Because we think of containers as, in a sense, competing against conventional virtualization like VMware products. Well, the big difference is that a full-scale VM has a lot of overhead because you have to have an operating system running. It takes significant CPU to run an operating system, but the more important resource is memory. So an operating system image consumes a fair bit of memory. So if I want to take a bunch of these VMs and run them on one piece of hardware, a lot of the RAM in that piece of hardware is going to end up being consumed by these multiple copies of the operating systems. Containers don't do that. They don't have that additional overhead. A container, taking a bunch of software and putting it in a container, effectively has zero impact on resource usage. It doesn't take any additional resource usage, either CPU or memory, because this layer that's doing the smoke and mirrors to trick the container into thinking it's isolated is very, very thin and very efficient. So there's a teeny tiny little overhead, but it's not much. This puts a limitation on what operating systems we can make use of, because a bunch of containers on one machine, they're sharing a single operating system. So the slide talks about that as a significant limitation on operating system choices. In practice, it's true, but it's really not a big deal. Not a big deal. Okay, let's get forward here. One of the things that it enables is the ability for people to make use of Docker as a platform as a service. If I have this standard mechanism for creating Docker containers, and I can hand them to an operating system to run, I don't have to run the operating system anymore. Now, I can look at this in a few ways. One way that this is made use of in organizations is an ops group will create an environment where Docker containers can execute. And they'll say, effectively, here's your environment. Now, development, you get a container, drop it in this environment, and it'll run. Effectively, we've created a platform as a service. We can extend that notion into cloud. So in a modern cloud like AWS or Azure, I can actually take a container that I've built and simply hand it to them, and they'll run it. This notion that we can simply take a container and treat it as a deployment unit and hand it to something to run, that's one of the things that makes containers so attractive to DevOps. Without containers, how do we take an application and put it into an environment? We have to essentially write all the code to manage the deployment into a particular environment and manage the configuration of that environment once we're in that environment. It's totally possible to do, but it requires a lot of tooling to do that, and potentially a lot of effort. And it potentially means that if I deploy my application into an environment where several other applications are running as well, then potentially what I do to configure my application could step on somebody else's toes. Docker changes this picture around considerably. What I can effectively do then is I can take my code, package it inside a Docker container early on in the build process. That Docker container now becomes the binary that I move around when I'm dropping it into an integrated test environment or a UAT environment or production environment. And all of the configuration is inside the container. I don't have to manage the configuration of the enclosing server anymore. Well, I do to be able to run the Docker containers. But for the applications, it's buried inside. And it's better than that. Can I have a place? Okay, so I'm skipping forward several slides here. There we go. There's this notion of a Docker file, which is essentially a build file. So here's an example of one that I can put as part of my build script and say, Docker, execute the things in the Docker file to create and configure that container. And at the end of that Docker file run, what I have is a container which is deployable. So I'm encapsulating all the configuration and shifting left all the management of that configuration and being able to put it under version control. So great capability. Docker as a product is important because it's the 800-pound gorilla in this space. There are a number of containerization solutions, of which Docker is by far the most popular. And because it's the most popular, it has the biggest ecosystem. It has the biggest tool support. There's a lot of integration into various tooling that lets you make use of Docker. And another part that's becoming increasingly interesting is there are public repositories that contain pre-built Docker containers that you can use as starting points. That's actually what's happening in this Docker file here. This statement from OpenJDK 8 is actually a statement that tells Docker, when you're building me a new container, go out to a public repository and get me the pre-built container that has OpenJDK for Java version 8 in it. Now, how do I know it does that? From the name, because I've used it. But it could be kind of anything. And it has kind of pre-built capabilities into it. I can, as an organization, leverage that capability and kind of pre-build an environment that doesn't have an application installed into it yet, but it has all the corporate stuff that I need, like logging services and security configuration, all those things. And I can put that in a private repository. And so a developer or an application team can create a new container based on that template that has pre-built into it all this configuration stuff already installed in the container that we want to make use of. Now, I could go on for a long time because this is such a rich area for value in DevOps. But in the interest of time, I'm just going to kind of wrap this up by saying that containerization and Docker in particular are absolutely not mandatory for DevOps, but they give you some tools that are incredibly valuable. They give you a nice, easy way of encapsulating deployment in a portable way. They give you a way of building and managing that deployable image. They fit really nicely into a continuous integration, continuous delivery pipeline. And they simplify the process of managing a deployment environment, because the deployment environment needs to just be able to run Docker run Docker images, rather than having to worry about how to be configured for particular applications. And there's a rich set of tools that are available and continually maturing around the ability to manage and orchestrate container execution. Tools like Kubernetes, you may have heard of. Well, what Kubernetes is an environment that lets you take a cluster of machines and configure them so that they can run containers. And you can tell Kubernetes, here are some container images, run them for me. Now, there's a little more to it than that, but that's the basic idea. And effectively, what some organizations are doing is creating what's effectively a little private cloud for containers inside the organization. Now, I'm going to close with the question that was asked. Are containers useful for larger monolithic software, or are they just useful for microservices? Well, this is a really interesting question. The Docker philosophy, the ultimate expression of the container philosophy, Docker has this idea that they push: one process per container. Now, that's the marketing statement. I mean, don't take that literally. It's not literally one process per container. But the idea is, in Docker's philosophy, the kind of way that containers should be used is to allow you to separate an application into individual components, each of which is deployed independently inside a container. And this is to allow you to isolate all the components separately. Doing so simplifies the configuration and management of those components. It makes it much easier to manage security around those components. And it allows you to compose solutions out of a bunch of components easier than trying to jam all those components in one place. And there's an architectural implication if you follow this philosophy. This is a great philosophy. I'm a big believer in it. But at the same time, we have a lot of applications that were built before this, or kind of legacy apps, they're monoliths, or you didn't think of it this way. Can you put them in a container? Yes, you absolutely can. You can totally put things like this into a container. At some point, you want to question whether you want to, though. If you have an application and you would dedicate an entire virtual machine to running that application anyway, do not put it in a container. You will get no extra value. The only value you get from the container is if you would have deployed it in, you would like to deploy it in its own virtual machine, but it's just too much overhead. So in answer to your question, yes, you totally can. Whether you get value from it is a different question, but they're definitely for much more than just microservices. Last thing about containers. This is still very much an emerging area. There's still a lot of practice and the tools are evolving. It is very definitely production ready, but it is production ready with some caveats. An organization should know what they're doing. An organization should take the time to make sure they have the right controls in place. And the controls you want in a containerization environment, they're a little different than the controls you'd have otherwise, in addition to. So it's a very, very valuable technology to look at, to look to adding to your toolkit. Don't rush into it too fast, but if you're not exploring it as an enterprise, not as an individual, but as an enterprise, you're potentially missing something that could be very valuable. We're running right on the end of 1:30, and I know I didn't cover all the material, but I had some great questions, which I thank you for. I do want to thank all of you for sticking with me through this rather long webinar. I hope that everybody's had value from it, and you should receive follow-up from WebAge with, I believe, links to the recorded session and the materials if you haven't gotten them already. Again, I very much appreciate that you shared your time with me today, and thank you, and I hope to run into some of you in a course one day.